Hello again and welcome to another video lesson with Mr. Trochet. We have 8.2.2 today. How close is my sample? And so basically we are going to get a sample and we're going to make sure, is this a good sample? Is this a bad sample? It's not the samples that you think about Costco. However, we're going to make inferences about these random samples. And inferences is right here, is a prediction. That's pretty much what it means. So what is your inference? What is your prediction from a random sample? So we're going to take a look at that. Again, got to throw in some fireworks here. Thanks for watching my video. All right, let's get back to it. So we have, sometimes when you take a sample, it is random and they don't represent the, the median or the average or anything like that. When you take a sample size, that's sometimes what you risk when you do a small sample. So for example, if you measured 10 trees, and you found the mean, you would get a number that describes those 10 trees. But does that describe all of the entire forest? I mean, do you have to measure trees from different areas of the forest or just the 10 trees that are in the front of the forest? You know, what makes it a good sample size and what makes it a legit, well, you can make an inference from it too, and a legit sample size from the forest. All right, so 841. So for today, we're going to talk about the robin. So American robins in yards are a sign that spring has arrived. You would like to know the average weight of an American robin in your town. So obviously you're not going to weigh every single robin, even if you could figure out how to catch them. So a small sample seems like a good idea. All right. So don't worry about this. We're going to use the student e-tool that's right here. And we're going to talk about this question. So part A, think about how you can take a random sample from the population of the robins shown here by the orange dots at the right. What thing would be important to do? Again, if you don't have this access, just click on this right here. You click on there and this will pop up in your iPad. What things would be important for you to do? I want you to discuss this kind of with yourself, obviously, if you're watching this video, but what would be important? So go ahead and pause the video. Give me your answer, what you think, but what things would be important to do? So the first thing that I think would be important is make sure when you choose a robin from this sample right here, let's say these are all the robins in the town. If you choose a robin, you don't want to choose the same one over and over and over and over again. So make sure when you, like I said, I want this one, that's 81. I don't want to just click it again and be like, okay, I'm going to choose this one again. And subconsciously, you don't know. Or if it's like a robin that you measure, what they do in real life is they tag it. So they clip it with a little piece of paper or a tag that knows that they measured this at one point, and then they let the robin go. Like they do it with sharks, they do it with fish and dolphins. They tag these animals so they are keeping track of them. So for us, in the sense, we're going to keep track of them by clicking here, and then we're going to drag it up here. So that's like how we tag it in a way. That's one thing, but you can think of other things too. Let's go on to B. Now take a random sample of 10 robins, drag them into the cage. Once in the cage, the weight of each robin will be shown. Each member of your team should do the same thing. So I'm going to take this one, and I'll take that's 2, and this one is 3. Ooh, 97, that's a big boy. Or girl. Oh, there we go. That's a big boy or girl. 115, 76, that's 5. 76 again. 78. Ooh, I want another big one. 91. Who can get the biggest one? 75. 86. That's 5, 6, 7, 8, 9, 10. Okay, that's 10. All right. And so we're going to do this sample here. Let me just look at the book real quick. Take a random sample, record the weights, same thing. So make sure you write these weights in your notebook. We have 81, 63, 97, 115, blah, 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 you know. Calculate the mean of your sample, all right? So we're going to add up all of these numbers. I'm going to be very quick because I don't want to waste your time, but usually you just write these out. So I have 81 plus 63 plus 97 plus 115 plus 76 plus 76 plus 78 plus 91 plus 75 plus 86 divided by 10. That's 83.8. 83.8. So we've got to make sure we do that. So that's 83.8. Do you think this is your mean is representative of the population? I think when I look at this, my inference is 83. It seems like a pretty solid number. Yeah, we have a little higher mean. We have an outlier of 115. We have an outlier of 63. Remember, outliers are the big highs and the big lows, or the low lows, high highs, big lows. I don't know. Anyways, small lows, big highs. That's what they are. And then, but it's around 70s and 80s sound pretty good. So that's going to be what I'm thinking. So 83.8. What inferences can you make about the population from your own sample? The thing is, it's random. My 10 is going to be more random than your 10 if you do this on your own. But I like to see, like, it's going to be between like 70 and 75 and 85. I think that's a good way to do it. 75 and 85, couple above, couple below. I think that's a good number. Let's see. D, compare your estimate of the population mean to the means of others in your teams. Obviously, we don't have anyone else. So in class, this would be a lot of fun to do as everyone gets their own averages and weights, and we kind of see if it's true or not. But is your mean the true average weight for all American Robins in town? No. Is your mean the true average weight? No. You need to measure everything to get the true average weight. That's definitely not the case. Are any of your numbers the true average? No. No one has the true average. From a small sample size, you don't have the true average. How can you explain any differences between the mean? So once if you're in class, you measure your mean, some may be higher, some may be lower, some may be exactly the same. But what you could do is if you got all the averages and then you average those, that might be a better indicator than one average by itself. All right, so think about that. All right, so 842, your estimate of the mean will probably be a little larger or smaller than the true average, as we know. But let's explore how much larger or smaller your estimate might be than the true average. So it says right here, follow your teacher's directions to add your estimate of population mean to the list of the rest of the classmates' estimates. Just like I said, once you take the average of everything, you can make a nice little histogram and everything. So what we're going to be doing here is I will see if I can give you some averages that you can create your own histogram with 5 grams. Yeah, well, that is actually 5 grams, 5 grams of weight. So let's pretend, so we have, I'm going to write this down here. So let's say we have 83.8. Let me give you another one. Let's say 81.2, 73.9, 71.0. Let's go ahead and do 86.7. And let's go 90.1. And let's go 82.4. And let's go 100. Just put 100 in there. Why not? So these are going to be your numbers that you can use to create your own histogram. So let's pretend these are all the averages of the people in your class, and you're going to go ahead and make a histogram. So that's 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8, 9, and then this one will be your 10th one. So we'll have a total of 10. So we're going to, well, actually, we'll do one more. Let's do 75, 76. Let's do 76, 76.4. All right, that should be 10. And then you're going to make a combination histogram and box plot. So combination histogram, let's go ahead and do that right here. We're going to start at 60, 65, 70, 75, because this is 60 to 65, right? And then this is from past 65 to 70 and stuff like that. 75, and this is 80, and this is 85, and this is 90, 95, and I have 100 somewhere, so I gotta just put 100 over there. 100. All right, you're gonna go ahead and plot these on your histogram as such. And then also you want to put these in least to greatest. So least to greatest. So that's going to be, for example, 71, 73.9, and so on and so forth. I'm not going to waste all the video time. You can do this, pause the video, write this out, least to greatest, and then you want to make a box plot of everything. So again, we want to find the median, all right in the middle, and then we want to find the Q1 and Q3 of from the median right in the middle, and this will be your box, and then you have the lowest here and then the highest over here, obviously to the right of that. Do your very best. If you're in class with me, we'll be working on this together, but yeah, try your very best, okay? All right, so I'm going to go ahead and clear it. What causes variation in sample mean? So variation is kind of like the how far it is away from the median, right? It's the variation is basically it's how far away, how many sigmas in that sense. So give me 1 second real quick. Okay. So variance, how different is it from like the median? How different is it from the middle of it? What causes a variation? Well, what causes a variation or a bigger variation is bigger birds or smaller birds. So like we have in this example, we have 115. That's a huge one. That's going to cause a bigger variation. And then this one is 63. And so that's going to stretch out your sample sizes, not your sample size, your whiskers on your box plot. And it's going to stretch out your histogram even more. So it's going to separate it from the middle of your box plot in the middle of your histogram. That's what causes it. That is, why are some sample means on your graph much larger or smaller than others? Again, that's why, because you can have a box plot like this, and then you can have a box plot like this. So this is a bigger variation, right? Because it's longer, and the outliers are so much farther away here and here. And these are tiny ones, and these are tiny variations because they're not as far away as from the median right here, and that's your median. All right. Why are so many sample means bunched up in the middle? Because that's more so of the middle response. That means your typical birds, most of your birds, 75% of your birds are going to be closer to the median. They're going to be bunched up in the middle. We even have that here. Let's think of what's the middle here. I think 78 might be the middle. So that's 1, 2, 3, 4. Four out of these right now are really tight in the middle. We have 2 outliers, that makes it 6, and then yeah, that means it's 86 is a little bit of an outlier too, but still, that's kind of where we're heading. Is most of the birds are going to be in the middle. See, within this interval, do you suppose is the true within what interval? Within what interval do you suppose is the true mean weight of the robins? Well, I think the true mean weight is going to be like around 75, 76, 78, even all the way to like 80. So I had like 86 over here. I think it's going to be like 76 and above. I think we only had one. So let me erase this real quick. We only had one bird that was below the 76 mark. So if I took this outlier out, this would be the lowest. So it's got it, like it's going to have probably start around 76, and I would say probably to 86. I think that would be a good, so 75 to 85, 76 to 86, that would be the main interval of what it is. So if I did one from like 60 to 65, 70, 75 to 80 to 85, right, on my histogram, I think it's going to be here. It's going to be big and big on these center. And I think these intervals, I think it's going to be between 75 and 80 or 81 to 85 or 81 to 86. And that's what I imagine. So 76, 86, I think that would be where our box plot is going to be kind of here. And then we'll have it like that. So anyways, that's kind of it. just wanted to go over that. We're just practicing a little bit. I would not super worry about if you're still struggling with box plots, but just know if I make a box plot and it's like this, what you need to understand is here is 75% of the numbers. This is the median. This is first quartile here, third quartile. So this is where the meat and potatoes are, right here, right in the center. So wherever this is, good. This is the outliers. So don't worry about those too much, but that tells you the variance. Okay. All right, that's pretty much it. I hope you enjoy this lesson. Just a little fun. Be a lot more fun in class, unfortunately, I know that. But I hope you have a great day and good luck on your homework. Let me know if you have any questions and come to office hours.